Hello and welcome to our fourth video about the Redstone guides. This one is going to be talking about the introduction of logic gates. And logic gates are used in every electronic device in the planet. They are just everywhere, everywhere, everywhere. Everything you do, from your electrical circuit in your house just to turn a light on, to every computer, cell phone, screen, even inside probably your watch, is a digital circuit of some sort to help run things. Now, a digital circuit to me is generally three different things: an AND gate, an OR gate, or a NOT gate. What I mean by an AND gate is that we have two inputs, input A, input B, and the output. And the output, this light, right now, is off. And what we're going to see is that if I step on this one input and turn it on, the light doesn't turn on. And if I turn this one on, so now it's got power, our light's still not on. But if that's on and this is on, we see our output is now on. So this works because, remember I said the redstone torches are very, very useful in the second video. What's happening is that this torch is getting provided power from this block, and so this torch turns off. These torches, though, are not getting any power unless our inputs are on. So right now there's no power going in, so they turn themselves on. And they provide power, and they're powering up this block, which turns off this torch. Now, what's happening is that when I turn on a single switch, I turn off this torch. But this torch is still on, and it's providing power, and this one's still off. And I have to turn off both of these redstone torches before there's no power here, and this torch can turn itself on. So this is what we call an AND gate. And this is its truth table. So a truth table is a way to understand every single possible situation for our input, every single possible situation for our input, our second input, and all the output. What's the outcome? So you can see that when a 0 means off and a 1 means on, that if input A and B are off, our output is also off. If only B is on, our output's still off. If only A is on, our output's still off. But if input A and input B are both on, then our output is also on. And so that's a basic truth table. We'll be talking a bit more about these as we go through the next session. They're very, very important to understand, and they really help you debug and find the problems with your advanced circuits, to understand what am I trying to do, what are all my settings, and what happens if I go through and change all my switches. What's the output? What's going on? Where's my problem with my circuit? Alright, the next gate is called an OR gate. And if this is an AND gate and we want input A and input B to be on so that the output's on, the OR gate is kind of the opposite. We're saying if input A is on, we have output. If input B is on, we have output. So what happens if we have both on? It's still on. So the only time it's off, if it's both input A and input B are both off, that's the only time our output is off. And we call this an OR gate because what we're saying is that it can be input A or input B on to generate an output that is on. So this or that equals this is turned on. So we can see from the truth table, if both are off, our output's off. If input B is on, we have power. If input A is on, we have power. And if both of them are on, we also have power. So very easy, very simple to use and set up. You can see I really don't have to do anything besides just wire these two together. Later on you'll see some more complicated uses for this that you'll need to use some redstone torches for to keep control over things, but this is the most simplest design for an OR gate in Minecraft. And the next one we get to, which is always useful, is the NOT gate. So the NOT gate, all it's doing is reversing our input. So when our switch is off, our input is off, the output is on. And when our switch is on, the output is off. So this is always useful for so many circuits when you're trying to determine, I want these two things to be met, but then when they are, met, I want the thing to stop working, or I want to prevent something, or I want to close the bridge, or I want to shut the door. And you'll be using this in conjunction all the time with these other gates to generate different, logic gates and circuits. So this is very easy though. You just power up a block by directing redstone into it, have a torch on the side, not on top, have it on the side, and then have your redstone coming off of that torch. And that is how you generate a NOT gate. Alright, now let's look at what we also call NOR gates and NAND gates. So all a NOR gate and a NAND gate are is we combine a NOT gate with an OR gate and we get a NOR gate. So here we have both of our inputs are off and our output is on. So that's a pretty typical gate. And when we push this, our output turns off. When we put input B, our output turns off. And if we have both of them on, our output's off. And so when we look at our truth table here, and we see, okay, the output's on only if they're both off. And if we go back and look at our OR gate, we see that it's off only when they're both off. So a NOR gate has reversed our output. We went from having almost always, on, there's only one time it could be off, to changing it so that there's only one time it could be on, and the other options are all off. So that's a good reversal of an OR gate, and we call it a NOR gate. Alright, and the same is very true for the NAND gate. We want both of these to be on so that our output turns off. And if one switch is not on, the output's on, regardless of which switch is not triggered. And if they're both off, the output's on. So this is always useful when, say, you have a door you want open most of the time, but if somebody triggers some specific setting, the door closes on them. And we call this a NAND gate. And you can see from its output 1, 1, 1, 0, because we have all off, only one or the other on, or both of them on. That's our truth table output. And if we look at this output for the NAND and we compare it to our AND, it's the complete opposite. So now it's 0, 0, 0, 1 instead of 1, 1, 1, 0. So just by adding a NOR gate to your AND and OR gates, you can completely change how their outputs work and use it to make much more complicated traps and puzzles. Alright, that's our first one, and the next video we're going to be examining some more complicated circuits and learning about a flip-flop gate. Alright, I'll see you there.